This is lesson 11.3, talking about geometric sequences. And remember, when we use the word sequence, what we mean is a pattern of numbers. So when we're looking at geometric sequences, this is the section that uses multiplication to move from one term to the next. Multiplication. Now down here, if you see things that are multiply or divided, so for example, up top here, let's say you have a sequence that's 64, 16, 4, 1, 1/4, etc. What you're using to jump from piece to piece looks like you're dividing by 4. That's true, but you want to focus in on the multiplication side of it. So you want to say, what am I multiplying by to get from piece to piece? And you're multiplying by 1/4. So anytime you see division, make sure that you convert it to multiplication with a fraction. Okay, so convert multiplication to multiplication with a fraction when you're doing these problems. So, for example, down below, this one here, jumping from term to term, we're multiplying everything by a -2. And we call that jumping term R. What's the ratio that gets you from term to term? This example down here would be R as +2. That's the common ratio. So, same as before, we want to figure out what is a formula that could help us find any sequence, any term in a sequence. So as we look at this sequence, this pattern right here, our starting term is a sub 1. So 2 times what would give us 8? Well, it's 2 times 4. 2 times 4 is 8. Next term, 2 times 4 gave us 8. What do we have to multiply to get to 32? And it's 4 again. So we start to see that 4 is our common ratio, our R. 2 times 4 times 4 times 4 is what gives us 128. And 2 times 4 fours is what gets us 512. So notice every time we're adding on an additional 4. So when we talk about this for any sequence, you're always going to have that first term, a sub 1. And then you're going to multiply that by a certain number of r's or ratios. For the a sub 2 term, you're going to multiply that by 1 ratio. For the a sub 3 term, you're going to multiply it by 2 ratios. A sub 4 was 3 ratios. And so we notice that the amount of r's or ratios is always 1 less than the subscript. So if your subscript is n, we will say that we're multiplying n minus 1 r's. So this is our formula. A sub n equals the first term times n minus 1 r's. So r to the n minus 1 power. This will allow us to find any specific term, or the nth term, if you will, in a geometric sequence, a geometric pattern. So to practice, we're asked to find the a sub 10 and the a sub n. When you have a sub 10 or a sub 6 or a sub 7 or whatever, then we're actually looking for a specific number or a value. We're saying what is sitting in the 10th position of this pattern. When we ask for the a sub n, we're asking for the formula. We're saying plug in the a sub 1 and plug in the r so that we can get the a sub n formula. So for this first one, we can see what a sub 1 is, sitting right here. A sub 1 is 1. And our r term that jumps us from piece to piece is -2. So we'll put those two pieces together and say a sub n equals 1 times r is -2 to the n minus 1 power. Because this is a 1 here, it's something special, we could say that it's -2 to the n minus 1 power. So either one of these is correct for our a sub n. Side note for you, here's what I don't want you to do. Let's suppose that your a sub n was 3 times -2 to the n minus 1. When you have a number out in front that is not 1, you are not allowed to combine them with the same power, because this power, the n minus 1 here, is only acting upon the 2. It is not acting upon the 3. So you need to make sure that in your formula, when you write it, you do keep them separate. All right, so that was our first thing, a sub n. Let's go ahead and find a sub 10. So a sub 10 means that we're going to do 1 parentheses negative 2, 10 to the minus 1. So a sub 10 equals 1 times anything is just anything. So negative 2 to the 9th. And here is where all your mad, right now the game 2048 is really popular, your mad 2048 skills come in handy. If you count up on your tiles, the tiles go up 2, 4, 8, 16, 32, 64, etc., right? Count all the way up to the 9th tile. And on the 9th tile, you get 512. And because it's a negative, and there's 9 of them, it's negative 512 for your 10th tile. All right, this one down here, we're asked to find the first term, and we're asked to find the r. So we're given a sub 2 and a sub 7. So we're going to write these out. A sub 1, a sub 2, 3, 4, 5, 6, a sub 7. A sub 2 is negative 6, and a sub 7 is negative 192. Now we can't even find a sub 1 unless we know what r is. What's the ratio, the thing that will get us from jump to jump? And this is tricky because there's a lot of jumps in here. It'd be so much nicer, right, if it was negative 6 space then a number. We could probably guess and check. But this is a lot. So we're going to use what we know about geometric sequence. We know that any number in the sequence is multiplied by r's to get the next term. So we can say, well, we're at negative 6. How many r's does it take us until we get to negative 192? So we count them up. It takes us 1, 2, 3, 4, 5 r's, or 5 jumps. So r to the 5th. And you might also notice that 5 here is the same as 7 minus 2. 7 minus 2 tells you how many jumps you have. 5 jumps, and if we multiply negative 6 times 5 of these r's, we'll get to the negative 192. Once we know that, then we can solve for r. So divide by negative 6. R to the 5th then equals a positive 32. And when we go to take the 5th root, and you can use your calculator for this, if you go to your math key, there is a xth root button that you can use, and you just put in a little 5 here for that. 5th root of r, and then 5th root of 32 gives us 2. So r is 2. Once we know that r is 2, then we can go backwards to get this term here. So if going forwards we are multiplying by 2 every time, we want to say, what did we multiply by 2 to get negative 6? And the answer would be negative 3. So several of your homework problems are going to ask you to either find r, or you're going to have to find r in order to find another term. So again, this idea of you have some early term times some number of r's, how many jumps, and that will equal some later term. This will be a very useful formula thing for you as you're looking at homework tonight.